Hi everyone. So, as I talked about in the last video, I have started with low level design and okay, let's jump right into the screen. Mm, all right. Okay. So, I came across this playlist and this playlist is really good. So, I skimmed over this playlist initially. I didn't give much importance to it, but this is a very good playlist. And this video that I'm talking about, this was the most in-depth roadmap that I could find for LLD and even HLD. So I'll be following the playlist. There are a lot of members-only content, so I guess I looked at different. So I'll use this playlist to stay in touch with all the topics, and I found some structure here about all the topics that I need to cover in low-level design. Other than that, there are also other playlists which are really good. Let's talk about low level design. So this playlist was good, and but I'll stick to this playlist. Right. So this is a playlist by Aryan. I don't know the full name, but this playlist was also good. I'll, however, stick to this playlist because this is the most in-depth covered syllabus that I could find for low-level design. So I studied about solid principles. This is the first step of learning low-level design, and uh, mm, this video is not going to be about solid principles. I'm not going to explain solid principles because I guess there are a lot of videos online which do it much better than I can ever do. I myself learned it, but I'll talk about a different viewpoint, a different way of looking at solid principles, which helped me to understand solid principles in a very beautiful manner. And I want to share that with you guys. So, first, I would want you to look at this video. This was a really good video. He talked about solid principles. He shaped my thinking in some manner, and this is a really good title as well. Solid principles. Do you really understand them? So you can go through a video and you can go through every single letter SOLID. You can understand that S stands for single responsibility principle, open O stands for open closed principle, Liskov principle. You can understand these definitions, but do you really understand them? And in order to really understand them, I guess, yeah, so I have also shared a link of the thing which I'm maintaining. This is the Notion page that I'm maintaining. So, in order to understand solid principles, I tried to understand why these principles exist in the first place. What does S mean? Why does single responsibility principle exist in the first place? And I learned that they solve a very big pain point. Every single principle in Solid is built and it exists because it solves a very massive pain point. So you can go through this. See, single responsibility principle. It doesn't talk about single responsibility principle, doesn't talk about your class needs to have just one method. That is not single responsibility principle. What it tells is that your class needs to have one responsibility. So you can use your class to solve one problem. You can use your class to look at just one responsibility, and it can have multiple methods to look at that responsibility. But there should be only one reason for which you change a class. So you can go through this entire. This is something which uh, these are obviously, so each solid principle exists to solve a very specific problem in code base, and these are the consequences of all of that. One thing which I really found helpful is to look at this. So uh, I understood them in a much better way when I looked at this. When I looked at what bad code really is and what bad code looks like, how it harms, what harms does it do, and how does implementing those solid principles will help, and how it changes that bad code into a good code and solving the pain points that existed. This is also something that I wanted to talk about. See, system design is something which is very, it is a skill which senior engineers take years of experience to build, and it is not something which I can learn by like going through a playlist like a movie, or going through notes like a novel. I need to uh, expose myself to a lot of code. What system design teaches you, I read this in an article, what system design teaches you is how, not how to write the most amount of code, how to code the most. It talks about how to take the best decisions about code. And in order to take the best decisions about code, you need to be exposed to a lot of code. You need to know what bad code looks like. And if you've not coded, you'll never know what bad code looks like. If you've not written bad code, it becomes very difficult to know what bad code really is and how to sniff bad code. So this article, I guess, will really help. We can go through some examples. So let's go through this example. Single responsibility principle. So this is an invoice service class. Now, this class has these three methods. So you can calculate the amount which will be printed on the receipt. You can send the email, you can send or print the receipt. You can also save it to the database. So this entire class is now doing three things at once. It is calculating the amount which one needs to pay. It is saving it to the database, and it is also sending an email. So the responsibility, it has three responsibilities. The reason why this will break is because when you want to change this, suppose you want to change just how you save to the database. Now, earlier you have written your test cases keeping in mind that your class has three responsibilities. Now, when you change this thing, there are a lot of possibilities that your test case will break again. Your test case will now start breaking. So you put a lot of time aside to write all those test cases, but because your class is tightly coupled, it is prone to failure. It is prone to, so changing one thing can affect other classes, other methods which it is tightly coupled to. You can also give it a better, so look at this class. So if you code it in this way, so if you have separate classes, so you have one email service. Now if you want to change that email service, you don't need to care about how you calculate the total amount. You don't need to care about how you save it to the database. You just need to care about how you send an email. So you can have test cases about this, you can have test cases written about this, you can have test cases written about this, and changing an email service just will make you need to have separate test cases to test that new logic. It won't affect logic for these other classes. It gets a lot more clear using this example. So open close principle. What open close principle talks about, that a class should be open for extension, but it should be closed for modification. Look at this class. So it is a discount service which we are giving, and if the type is student, then the discount is 10%. If the type is a VIP, then discount is 20%. So suppose you are a testing engineer, and I have written a lot of test cases for this class, keeping this class in mind. Now, while I was writing test cases, the thing that I had in mind is that my class has two if statements. So I'll write a lot of test cases. Suppose I want to give more discount to people who play sports or who have gotten some kind of accolades in sports. Now I'll write another if statement here. So I'll change this and I'll write if type equals sports, return amount multiplied by 0.7, so 30% discount. All the previous test cases that I wrote, keeping just these two if statements in mind, will now break. That is what open close principle talks about. This is the pain point that open close principle solves. So if you now code this exact thing in this way, so if you have a different class, now it's not there's not spacing in between of it. So implements here is different. So class student discount, implements. So this is different. Implements discount. So if you have different classes, subclasses, which are implementing this interface discount, now if I want to have a separate class, separate discount for people who play sports, I can just have another class and I can write test cases for that class. My previous test cases, which were written keeping this class in mind and this class in mind, will not break. That's it. You can go through all these things yourselves. I also have I learned about mutability, and like it did some kind of a refresher on mutability, getters, setters, and mutability and immutability. How setter changes reference rather than like copying and like changing exactly. So it changes reference to the memory, and Java garbage collector. So suppose you have a string Alice, and now you want to change that string using a setter. So you set that name to Bob. What it'll do is that it'll not change that Alice name to Bob. Alice will stay in memory. It'll make a new reference pointer, and it'll point to Bob. But since Alice is now no longer being used, Java garbage collector will automatically clean the memory that was assigned to Alice. This is something of what mutability is, so I needed to go through it. So these are the consequences I talked about. These, and I also got this from ChatGPT. So I gave this prompt to GPT, and I wanted to practice more and more because as I talked, I learned. I guess just watching a video, watching any video, following any playlist, and just watching a video and then moving to the other video didn't help me learn much, or didn't give me that satisfaction that watching this video and then solving a lot of questions regarding solid principles and seeing how bad code really looks like, that helped me a lot more. In a way that after I watched the video, 20 minutes after the video, I didn't know what D stands for. So I didn't know what I stood for. But after you actually go through this exercise, this is a really good exercise that GPT gave me. So after you go through this, I guess it'll really stick inside your head. So we'll talk about this. So we talked about this. I'll go through some examples. So inverse printer, again, we talked about this. How is it wrong? So apart from solid, let's talk about what is really happening in this class. This is a public inverse class. Now these are two variables. Now these are private. So you can't access these variables outside of this class. So you need to have getters and setters for this class, right? So this is what you have. You have a getter and setter. So I guess did they have a getter or setter? No, they didn't have a getter or setter. So you need to have a getter and setter for this class if you need these things. Now it calculates the amount of money, and it also saves to the database. It also prints an invoice. Now these are more than one responsibility, and how you write a good code. You write a good code in this manner. You can look through the code. This example is good. This example is good. So we didn't talk about Liskov earlier. Let's talk about Liskov here. So look at this class. Look at what is happening in this code. So there's a worker interface, and there are methods that a worker will have. So an interface is what? An interface is a contract that any other class which is implementing that interface will need to satisfy this contract. So in this contract, an interface will not tell about how to implement this function or also this method. But you need to implement. So any class which is implementing this interface will need to define a method for this specific task. So in work, you need to define a method for work, you need to define a method for eat, and you need to define a method for sleep. So a human worker will implement worker. So we overrode the worker method, the eat method, and the sleep method. But if you have a robot worker, now out of all these things, a robot worker will not eat, and a robot worker will also not sleep. So this interface, in a sense, provided you wrong expectations about classes which will implement this interface. So it, in a way, lied about its contract, because a robot worker is also something which is implementing worker. You are letting it implement worker. It will not give a compile time error, but it will not eat. It will not sleep. So it'll throw an exception. Now this will cause a runtime error. It will not cause a compile time error, and runtime errors are much more harmful than compile time errors. So if you're not able to get this, I guess revise Java and revise oops. Then you'll be able to understand what this is. This is a very simple thing which I'm talking about. So that is it. Interface segregation principle. So what you need to do is that you need to make different kinds of interfaces, and you need to give a choice to the classes which will implement these interfaces, that what interface do they want to implement. So this is it, and that's it, right? So you have a workable interface, you have a feedable interface, you have a sleepable interface. And now a human worker will implement all these three interfaces because it needs all these methods and will define all these methods. But a robot worker will just implement a workable interface. That's it. And that is something which I want. So that is something which you need to separate these things out. It will not cause a runtime error if you code in this manner. And there's also one thing which I learned many times. Many times this interface segregation principle in turn causes Liskov substitution, like breaks Liskov substitution principle. So these are all my learnings, and it can be all haywired. But I guess I was really excited to learn Solid in this manner, and it really stuck. So I guess that's it. I learned about solid principles, and I also learned about some patterns in the past, in yesterday. And yeah, the patterns. The thing is that again, I like to point out the same thing which I talked about. It is a skill which is uh, so yeah, it is a skill which senior engineers acquire over a good amount of time. And in order to get that skill, in order to get that muscle inside of me, I will need to go through a lot of code, and I'll need to code a lot so that I'm able to do justice to this thing which I'm learning, and it is very beautiful. It's really great. Yeah, I have. I'll mention the link if anyone wants to follow. I'll mention the link in the pinned comments about the resources that I had. I guess that's it. It is fun learning system design, I guess. All right. Bye.